Welcome back, everybody. We're going to pick up at question 5, which is about branch prediction. So in this question, we are given an example C program, and we're kind of asked to determine like the branch patterns that exist and then evaluate based on these numbers, whether like based on these patterns, whether we would correctly or predict or incorrectly predict them given it looks like a local 2-bit counter branch predictor. So the first step of this type of question will ask us how many branches are taken versus not taken for each conditional statement in here. So let's get started. So this function void sampler has 4 branches. Oh God, there goes my iPad. Oh, it looks like it was. Oh, there you go. So it has 4 branch statements. So the first one is this first for loop. And essentially in a for loop, we're only going to take the branch. We're going to take the branch every single time. Or sorry, we're not going to take the branch. We're going to have two branches, right? We're going to have the initial branch, right, B1, and we're going to have the second branch, B4. The first branch is the conditional statement that kind of breaks us out of the loop. And the second conditional statement is one that happens regardless, and it jumps us up to the first conditional statement, right? So like down bracket's going to jump us up here. So that B1, we're essentially going to only take that branch once, and it's going to be the very last time. So the question is, how many times are we going to do this? Well, because this is kind of a for loop and we're iterating, I'm not going to take it at 1. I'm not going to take it at 2. I'm not going to take it at 0, 1, 2, 3, or 4, but eventually I'm going to take it at 5, right? And so for branch 1, I'm going to take it once and not take it 5 times. For branch 2, and then branch 4, I guess would probably be a better spot. Remember, we're going to jump back every time. So how many times we're going to jump back? We're going to jump back every time the loop runs. And so our loop's going to run 5 times. And so we're going to take that branch 5 times, and then we're going to not take it 0 times. So then moving on to branch 2, so this inner for loop is going to run an F number of times. So F, it looks like, is 3, and we never change that value anywhere as far as I can tell. So this inner loop is going to run 3 times, but it's going to run 3 times every time this outer loop runs, right? And so like within each loop, we're going to not take it, not take it, not take it, and take it, right? Each time the outer loop runs. So the outer loop runs 5 times. And so the inner loop is going to do that 5 times. So it's going to be, within this each one, I'm going to have 3 no's and 1 yes and 1 taken. And so if I multiply that by 5, I'll get 15 not takens and 5 takens. And then B3, similar to B4, we're going to jump back every time the loop runs. So every time this loop is every time the outer loop runs, we're going to have 3 jump backs, right? But I'm going to have a total of 15. And so I'm going to have 15 takens and 0 not takens. Great. So then we are asked how many branches are correctly and incorrectly predicted using a local 2-bit counter initialized to weakly not taken. The way I personally like doing this, so I'll be real, when I took this exam, we were allowed to like use external resources as long as we weren't using any other people. So what I did is I wrote a simulator for a 2-bit predictor really quickly, and then I used that. But I guess if I didn't have access to that, like this case, essentially I have strongly taken, weakly taken, weakly not taken, and strongly not taken, right? And essentially I'm going to fall at one of these spots in any, so. And then, okay. And so like at any particular point, I can have a transition between each of these two states. And so what I'll do is I'll just kind of simulate it through it, walking through it by hand. So we can start with branch 1, right? So it's going to, the 2-bit counter is initially going to start at weekly not taken. So we're going to be here. And so the first time it runs, we're going to predict not taken. We're actually going to get it correct. So I can just do it like in tallies. And then we are going to transition. So now I'm going to be at strongly not taken, right? And then the second prediction, I'm going to predict not taken again, and I'm going to get that correct. And I'm going to keep getting it correct, and I'm going to keep staying at strongly not taken because you can't, you don't need a transition for there if you're getting it correct. So I'm going to get it right 5 times. And then that last one, I'm going to predict taken. I'm going to get it incorrect, right? In fact, I could just write 1. And that will cause me to transition back to weekly not taken. But regardless, if I turn that into a number, I get 5 to 1. And I can kind of do the same thing for all of these. Oh, geez. Cool. Okay. So then for branch 4, I'm just going to follow the pattern I used earlier. I'm taking every time. So the first time I predict, right, it's going to be initialized to weekly not taken. And so it's going to go from, so I'm going to get it wrong the first time. Then it's going to go to weekly taken, right? And I'll predict taken. I'll get that correct. That'll transition me to taken. They're strongly taken. And I'll get that correct and correct and correct, right? And so I end up getting this correct 4 times and I end up getting it incorrect 1 time. So branch 2, so essentially the pattern that we're going to see at branch 2, remember this persists across the outer loop, right? So the overall pattern that I'm going to see is not taken, not taken, not taken, taken, not taken, not taken, not taken, taken, not taken, and so forth, right? So we're going to initialize to not weekly not taken. We're going to get predict not taken. We're going to get it correct. That'll transition us to strongly not taken. We're going to predict again. We get there, we stay there, we stay there. And then we get it wrong. We get taken, right? So that will result in us transitioning back to weekly not taken, and we'll get it incorrect, right? Note that in doing these 4 predictions, what did I start out at this prediction? I started out at weekly not taken, and then I went 3 for 4, and it ended at weekly not taken. So if I ran this again, I would get the same results. I'd go 3 for 4 again. I'd go 3 for 4 the time after that, and the time after that, and 3 the time after that, because I start at weekly not taken and I end at weekly not taken. So if I want to generalize this, I know that every time I run that loop, I go 3 for 4. And so I can generalize this and say that it's 3 times 5 because I'm running that loop 5 times. So it'll give me 15, and this will be 1 times 5. So I'll get 5. So I got a 15 to 5 rate. Lastly, we're going to look at branch 3. So branch 3, what it's going to look like, its pattern is essentially going to be taken, 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 right? So it's going to be all takens. And so similar to branch 4, the very first time I run that branch, I'm going to get it incorrect. I'm going to predict not taken. But then I'm going to, jump over to weekly taken. And I'm going to get it correct again. And I'm going to end up at strongly taken, right? And because I'm going to continue guessing or predicting and getting the result of taken every time, essentially, I'm only going to get the first prediction that I make, one where I was started off at weekly not taken, incorrect. Every other one I'm going to get correct. And so remember, I had a 15 here. I'm 15 times I'm going to take. And so 14 of those times I'm going to be correct. So let me clean this up really quick. No, what I wanted. Cool. So I think we ended up with 5-1 here. We ended up with 15-5 here. We ended up with 14-1 here. And we ended up with, I think it was 4-1 here. Yeah. So the main tricky part that I think some people might have stumbled over is that remember that your branch predictors in your inner loop persist across the outer loop, right? So instead of getting something like, I guess it would be 3 to 12, or no, it'd be 5 to 10. Instead of getting 5 to 10 here, we got 14-1 because that branch predictor persists. Okay, so that's question 5. I'll pick up next time at question 6.